Back, or I guess I'm welcoming myself back if you were already here, to the stream. Sorry about that. My internet is crap right now. I share it with a lot of people, so they're probably watching TV or playing League of Legends or something. Anyways, back to it. I'm in arcade mode on Code Fights. Still in the intro phase. Got a lot of stuff to do here, so a lot of exciting stuff. Almost increasing sequence. Look at all these fun names. Land of Logic. Dark Wilderness, that's scary. So we're almost through the edge of the ocean. Okay, so almost increasing sequence. Given a sequence of integers as an array, determine whether it is possible to obtain a strictly increasing sequence by removing no more than one element from the array. Oh, okay. So let's take this. The output should be false. There's no one element in this array that can be removed in order to get a strictly increasing sequence. Interesting. Very interesting. So how can we determine this array right here is false? Right, here's an input that we can use, apparently. We have a bunch of inputs that we can use. It's like, okay. Yeah, this is a hard one. So how do I know? I guess I can look at the sliding window, right? If it was just... So a sliding window, if I could say that my window slides this way, right? X. X. Uh-oh, whoops. X. So my window is indicated by those two X's. So I compare those two X's, and I say, hey. Oh, I guess what I can do is just go through and remove the 1. My sliding window could be like this. Right? Then I can say is I could go is 2 greater than 3? We can say is the third one plus 2 greater than index plus 1 greater than or equal to how about we have a sliding window of 1? Let's just start 2 with that. can say yes. Are these two increasing? Yes, they're increasing. Go on. Are these is this one greater than this one? No. Sorry, my son is calling me. Okay, well, so I say these two, is the second one greater than the first one? No, it's not. So what can I do? Can I remove it? And find a greater one? I don't like this input. I need something better. This one's obvious, right? I have a sliding window. Is it greater than? Yes, it's greater than. 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 Is it less than? Or is it greater than? No, it is not. So remove this one from it. Now that it's removed, we say like removed one, true, and then we say is it greater than? Is it greater than? Yes. Boom. So that should work. We'll have a sliding window of 2. So we'll have a bool. Bool moved 1 equals false. For int I equals 0. I is less than length. Normally we would do length, we would just do less than length, and that will get us from 0 to the last index. But since our sliding window is actually 2 elements here, and this is our I right here is represented by the first x, then we don't want x to go over here, because then this will be out of bounds when we go to check it. So really what we want to do is stop at the one before, so that's length minus 1, minus 1, plus I. This is going to be weird, but let's do it. Okay, so if sequence of I is less than or equal to sequence of I plus 1, Then we continue. Continue is a keyword in C++ where it allows you just to go straight through and iterate to the next loop iteration without going through the rest of the code here. So we'll immediately iterate. We'll say it's greater than or equal to. Great, let's just continue on. Else. What does that mean, else? That would mean that the sequence at I is too big. So we need to remove. I always forget the reference for it, but we're going to go to our good old handy C++ reference. Vector. And we'll say oh man, is there none? Erase elements. Gotta use a fancy iterator. So we have to say sequence dot erase sequence begin. No. Plus I. So what does that mean for us? It means we need to we want to delete the one that's outlying. So we have a 96 here, like we did before. Or even something 9, just do 9 for its sake. We delete at I plus 1. You know what? Let's just make this code a little bit simpler. We'll say if the code at I plus 1 is greater than I don't know if it wants I if it equals case or not, but this would be increasing. So, and then we'll move this case up here. Oh, I can't. Oh, you silly. Cut that. Paste that. Boom, boom, boom. Okay, that's a little bit neater. We say we want to erase it because it's too great. Uh-oh. Oh, wait. Sequence I is less than or equal to then we'll erase. Yeah, that should work. Then we'll say one. if removed one, then return false. So this is a little short circuit. It's just saying, hey, if we've already removed one, this is true already. We must have already hit this code once, therefore we've already removed one. So we just return out saying we can't do this. We can't complete the problem without removing more than one number. So then if we hit that, then whatever. If not, we're going to remove it. Then we're going to say moved 1 equals true. That's wrong, right? Because it's I. That's the smaller one. Yeah. Or I is the larger one. In this case, we want to be backwards. It's true. And then we're going to do something funky here. Say we remove it, right? Now we need to actually make I go back 1. Which sounds crazy, but that's whatever. Don't recommend doing this. Playing with the iterator or the loop variable in the loop can get complicated, get messy. But whatever, it works. Maybe it works. We'll see. Run the tests. Just want to ship it, you know? Okay. Oh, I always do that. Sorry, I meant sequence dot size -1. Now let's do it. Okay. So some cases it's working, some cases it's not working. Let's figure out what happened. That's where that comes in. Now let's run the tests. Dang it. I thought I had the silver bullet there. More tests actually failed. So what happens? So now we gotta do this on paper. Figure out why that didn't go. So what do we do? Removed 1. So what I'm going to do now is the test failed, right? So I'm going to run it through on paper, quote unquote paper, and test it instead of trying to add print statements and stuff. I'd rather just do it manually. It helps me practice. If you're in an interview, a lot of times you're not going to have a coding, you're not going to have a compiler, you're just going to have the whiteboard. I mean, we're seeing more and more of these online type interviews, but when you're at a whiteboard, you're going to have to learn how to run your code on paper, as it were. So we're going to try that. Remove 1 equals false. So now we have I equals 0. I equals 0. So now we have I'm going to add little x's right here to keep track of my I and my I plus 1. So if sequence of I plus 1 is less than immediately, that doesn't work. Sequence of I plus 1 is less than. Oh, if I plus 1. Wait, is greater than. Yeah. If I plus 1 is less than. Is 2 less than 1? No, it's not. So we iterate. We move on. I is now 1. Let's move this guy up. If I plus 1 is less than I, it is, then remove 1 equals true. Equals true. Sequence dot erase. Sequence dot begin plus I. Plus I. So we remove this element. I gotta make sure. Where's Victor? Vector dot begin. Okay. So I think we removed it there. I assume that's what happens. Right. And then remove 1. Oh wait, we did that verse. Then remove 1 equals true. And then I minus minus. Oh, you know what? That won't work though because. So, anyways, we go back to 0. Now, I is equal to 1 again. Because it goes up. Okay, so maybe that works. And then so I guess they don't like this. They don't like the consecutiveness of it. So what needed to happen before? I guess this needed to remove this one. Maybe use a while loop instead of a for loop, maybe with a little more control. Int index equals 0. While index is less than sequence size -1. If sequence of index is less than sequence of index +1, then we're gonna room plus index. Great. Else, if that means it must be greater than or equal to. Right, so if it's greater than or equal to, then what are we gonna do? If moved one, it means we've hit one that we need to remove. If we remove one, if we've already removed one, return false. If not, let's continue on. So we'll say we're here, right? This one doesn't need to remove. That's the problem, is that when I look backwards, then I delete, I increase my index, right? And then I delete this one. If I remove it, then I also need to go back one. Yeah, so let's try that. Let's see if that works. Oh, and then I'm worried about going out of index on that one. I won't have to worry about it because I'll only ever have to go out of index once, and then it will return immediately if it tries to do it a second time because of this statement right here on line 8. Yes. So let's try that. What we're going to do is going to remove sequence dot erase sequence dot again plus I. Let's get, where's erase again? Erase. Yeah, so plus I should be fine. Plus erase. And then so let's just do that here. Start over. False. Alright, starting over from scratch. So, remove 1 equals false. Yes, it is. Int index equals 0. Yes. While index is less than sequence size minus 1, which it is, if sequence of index, which is 0, is less than sequence of index plus 1, which it is, index plus plus. Boom, boom, boom. Right? Good. Now, L, and now we iterate. We're done with the loop. Now, while index is minus sequence, it is. Index is less than sequence size minus 1. It is. This is actually 1 now. If sequence of index of 1 is less than sequence of index plus 1, which is actually 1. This is 2 and this is 1. Is 2 less than 1? No, it is not. Else, if removed 1 returned false, removed 1 equals true. So we erase the ith one. Delete. Now we do is index equals still at I, so 0, 1. Sequence minus size. Sequence is 3 minus 1 is 2. Is 1 less than 2? Yes, it is. So now we can move on with it. If sequence of index oh, I've already failed once, didn't I? Do I need to go back one? Minus index. This will probably fail. I'm just gonna run it. Index. That's what I meant. It's gonna blow up. I know it's gonna blow up. Yeah. Yeah, what is it gonna do in that first one? Doesn't know what to do. This is a head scratcher. It's supposed to be easy. What if I did, what if I didn't actually remove it? What if I just skipped over it? Right? I realize now I can't go backwards because or the index can't go backwards because then I'll skip out of the loop on the first run. It's possible on the first element to go backwards and be out of index in the front of the array. So what if I great. And then I jump forward, right? And then, unfortunately, nothing else gets pushed forward. I delete 2. Then everything shrinks back. If I shrink everything back, but I need to be able to check. What if I just do it twice? What if I go through and check it, do it twice in a row? Oh, that would be annoying, wouldn't it? What if it looks behind it? What if you started here, and then our sliding window went backwards? We started here. Is O greater than X? It is. Continue on. Is O greater than X? No, it is not. So that's the same thing, isn't it? Doesn't matter which way you go, forward or backward. Well, that would mean that everything goes in a strict decreasing sequence as well. Yes. Okay. I think I have an idea, guys. What if I start at the end here, and I say my index is really like 3? And we stop. Wow. Well, index is greater than sequence. Int index Oh, I guess we need to do some base cases here to get this out of the way. So if sequence dot size is equal to, oh, they already did that. Constraint length is 2, so we don't have to worry about that. We know the length is at least 2. index equals sequence dot size minus 1. Equals sequence dot size minus 1. And while index is greater than 1, if index is greater than index minus 1, index minus index dot end minus index minus. Do I need to do that? So let's say I start here. Remove 1 equals false. Int index equals sequence dot size minus 1, so that's 4 minus 1 equals 3. While index is greater than 1, it is, so we enter sequence of index, so it's 0, 1, 2, 3. This one is greater than sequence of index minus 1. 3 minus 1 is 2, is the 0, 1, 2 index. Is it greater than sequence of index greater than index minus 1? It is. So index minus minus. Two. While index is greater than 1, is index greater than 1? It is. Whereas index 2 is greater than 1, so good, we'll enter in. Sequence of index 0, 1, 2 is greater than sequence of index minus 1, which is 2. Is that true? It is false. So if remove 1, which is false, so or it's false right now, so we'll just continue on. Sequence dot erase sequence of end minus index 1, 2. So now we remove it. Index minus minus. Remove 1 equals true. Maybe we don't move this. Maybe we don't need this. Oh, wait. Right? We just remove this down. Good. I feel like I just created the symmetrical problem on the other end. So maybe I'll just add it as if index is greater than sequence dot size is greater than sequence dot size minus 1. Index minus index. So I'll catch that corner case. We don't need to remove it here. So now, remove some stuff. Boom, boom. No, no, not you, not you. You. So, delete it. Wait. Delete it. Yep. This is now true. T. Great. I think this is gonna work. I just want to run the tests. I don't even want to chew it on paper anymore. I don't like this anymore. I don't like that. And I'm almost done streaming, so I need to finish this. Ah! How could you fail? What's the issue here? I feel like this needs to be equal to. Yeah, that should. I blew something up. It shouldn't take this long. Yeah, blew it up hard. It's even worse now. I'll remove that. Okay, I wasn't able to figure it out, but we'll figure it out next time. I'm gonna leave it here as is. I'll give it some thought, and then we'll come back to this one. Anyways, thanks for watching, and I usually stream from like 7:30 to 9. I guess that'll be my normal schedule. So catch me back later when I'm streaming again. We'll try to conquer this problem, get through it together. Thanks. See you guys next time.